This video is about network interface for CDMA system. So this block diagram, it is going to have give us the analyzed that is from how the PSTN is got connected to the MSS mobile switching center using which channel, and how the base station system is going to be connected to the MSSC, and how these blocks, that is the switching systems, are going to be connected using the which channel. That is what it means, the network interface for CDMA system. So let us deal one by one. The system communication links, that is equipment vendors are still using the legacy channelized, that is the T1, E1, J1 copper pairs of connectivity to form the mobile switching center to the PSTN. So the CDMA equipment vendors have started to add the fiber optic interface delivers on its signals a data rate of 155.52 megabits per second as shown in the figure. The different network interfaces for CDMA systems are shown in the figure. The control information is used for interface between the MSSC and VSSC. Subcarrier devices, that is, it is generic term used to describe the several types of wireless phones and the data service that perform CDMA and coding and decoding and encoding operations for the transmission of voice for data in wireless mobile environment. Each subscriber device is a band or a set of radio band over which it can operate and various modes of possible operation. What is that is the CDMA channel concepts. That is the next part of it. That is the CDMA basics. So under this, the cellular telephone network use the various control and traffic channel to carry out the operation necessary to allow for the setup of a subscriber lady or the ring for the transmission of either the data or a voice conversation and the subsequent system support for the subscriber mobility. The CDMA 1 and CDMA 2000 cellular systems are based on the use of CDMA technology, provide the additional user capacity over limited amount of radio frequency spectrum. So this is accomplished by using the spread spectrum and coding technique that provides for numerous radio channels. The basic spectrum spreading operation is as shown in the figure, that is the orthogonal Walsh spread codes are used for channel encoding. So this is what Walsh code, so which is data 1 and 0 being transmitted with the orthogonal sequence. So it is getting multiplied, XORing the data. Here you are able to see exclusive ORs, that is CDMA transmitter and the CDMA receiver. So this is the coded sequence being sent and it is going to be decoded at the receiver end. So 1 and 0 being added with the orthogonal sequences, and these two are going to be exorgonal, that is 1 XOR with 1 is 0. So you are able to see here 1 XOR with 1 is equal to 0. So 1 exclusive that is 0 1 and 0 exclusive OR is 1. So 0 1 exclusive OR is 1. So here it is 1 exclusive OR is 0 is that is 1 exclusive OR 1 is 0. 1 exclusive OR 1 is 0. So this is how it is going to be coded at the transmitter end, and the sequence are going to be decoded at the receiver end. Next it is so next it is the IS95 CDMA channel is an Arrow and brand radio systems. So the bandwidth is limited to 101.5 megahertz at the chip rate of 1.22 megahertz chips per second. So the system is intended to provide the voice and the low bit rate data serving using the data circuit switching techniques. The data rate varies from 1.k kilobits per second to 9.6 kilobits per second, and the forwarded that is the base station to mobile station and reverse mobile to base station link. The structures are different and each is capable of distinctive capacity. Forward transmission is coherent and synchronous, while the reverse link is asynchronous. So the channelization in each link is achieved by using 64 chip orthogonal codes, including provision for pilot synchronization, paging and the network access. Consequently, the number of active users able to simultaneously access the network is limited by the level of interference and the service provisions and the numbers of channels available. So in IS 95B, an active mobile always has a fundamental code channel at 9.6 kilobits per second. When high data rate is required, the mobile, the base station and assign mobile up to 7 supplementary code channels. So the uplink frequency is 1920 to 1980 megahertz, and the downlink is 2110 to 2170 megahertz. So that is the frequency division multiple axis, and W, that is the version of WCDMA will operate in either the following bands, that is the other band is 1850 to 1010 megahertz. Downlink frequency it is 1930, that is 1930 to 1990 megahertz. So the 3G PP architecture of the universal mobile telecommunication system is composed of IP based core network, that is CN, and connected to the user equipment through the UMTS terrestrial radio access network. So the USRN UTRAN, that is the UTRN, consisting of a set of radio subsystem, radio network subsystem. So that is the network controller is responsible. So the network controller is responsible for the handover the decision that required required for signaling to the user equipment. So each subsystem is responsible for the resources that is set of all the cells, and each node B has that is a node B has one or more cells. So next is the CDMA channel concepts. So in CDMA channel concepts, a very much important topic, that is the forward logical channels, pilot channel, synchronization channel, paging channel, traffic / power control channel. So this is what you are able to see the diagram. So which is of that is the basic spreading procedure used in the CDMA forward channel. So here the input is going to be a channel dependent symbols being provided to the Walsh code, and that is been given to the two channels. One is I channel and the other one is the Q channel. That is the I channel pilot PN sequences at the rate of 1.2288 chips per second, mega chips per second. That is the I channel and the in phase and the Q channel. So been forwarded after getting multiplied with the pilot sequence PN sequences, pseudo noise sequences. So that has been given to the baseband filter. So from this it has been given to the that is the next system. So the basic procedure used in the forward CDMA journal is as shown in the figure. That is the digital signal to be transmitted over a particular forward channel is spreaded by the first exclusive ORing it with the particular Walsh code. Then the signal is further scrambled in the in phase and the quadrature lines by the two different short pseudo noise spreading codes. So these short PN sequences spreading codes are not orthogonal codes, but they are excellent cross correlation and autocorrelation properties that make them useful for this application. Each channel is spread sufficiently over the entire bandwidth of 1.25 megahertz channel. The short in phase and the quadrature phase Q, that is the spreading codes are generated by the two linear shift registers with the length of 15 and the set of polynomial values used to configure the feedback path. So this channel element is linearly combined with the other forward channel element signal, amplified and composite of band passed and band pass signal, and it is transmitted over the air interface. The short film spreading codes provide the CDMA system with the ability to differentiate between the different base station or the cells transmitting on the same frequency. So same short PN sequence is used by the all CDMA base stations. However, for each base station, the PN sequence is offset from the sequences used by the other area base station. The offset is analogous to the frequency reuse plans described for the access techniques. So the use of this office team requires that the base station used in CDMA is must be time synchronized on the downlink radio channels. This precise timing synchronization is achieved through the use of the global positioning system, purchase system time that has the required accuracy. So the initial 95 CDMA system implementation uses 4 different typical types of logical channels in the forward direction: the pilot channel, synchronization channel, paging channel, traffic and power control channels. So this is what the CDMA base station timing offset reuse pattern. So you are able to see that is a 32 6 is been using here. So 6 is been using here, the same channel is going to be using here, okay, and set of frequencies. That is what the beauty of CDMA. So again here the channel so 6 is also used here. So this is what the area is getting divided as the hexagonal shape. So each hexagonal is going to use the one set of frequencies. So the same frequency can be used in the other cell which is far from the it's the which is far from the frequency, that is the same frequency hexagonal area. So here it is the pilot channel. So pilot channel is going to have all zeros as the input, and it is been given as the Walsh code, and it is going to generate the sequence that is of getting multiplied. All zeros are getting multiplied with the Walsh code, and it is going to generate the chips of 1.2288 mega chips per second, and it is been given as the I channel and the Q channel. So I channel pilot sequence at the 1.288 mega chips per second, and the Q channel pilot PN sequence at the 1.2288 mega chips per second. That is the baseband filter to the QPSK RF modulator, and it is going to generate the I channel signal and the Q channel signal. So the CDMA pilot channel, it is used to provide the reference signal for the STs within the cell. The figure depicts the generation of pilot channel signals. The all zeros Walsh code is used for the initial signal spreading on the sequence of all zeros. So this results a sequence of all zeros that are for the thus producing the short PN spreading sequences, and the resulting in a sequence of zeros and ones. So I and Q signals drive a quadrature modulator. Therefore, the resulting pilot signal is unmodulated spectrum signal. So the short PN sequence is used to identify the base station, and the pilot signal is transmitted at the fixed output power, usually 46 dB stronger than the any other channel. So the pilot channel is transmitted continuously. It is used to the phase difference for the borrower, and the modulation of all other channels. It is also serves as the reference for the signal strength measurement and other signal power comparison. So next is the synchronization channel. So the synchronization channel is used by the system to provide the initial time synchronization. So as shown in the figure, this is what the synchronization channel. So as shown in the figure, that is a synchronization message which is of 1200 bits per second being given to the convolution encoder. So later it is been that is the code symbol is convolution after convoluting at the rate of half, it is going to be 1 by 2, it is going to be a 2400 bits per second. Then the symbol repetition and the modulated symbol is going to be at the rate of 4800 bits per second, and the interleaver between them, and it is considered as 4800 bits per second, and it is the wash code is also getting multiplied. So later it is been given as the Q channel and I channel pilot channel been created, and it is going to transmit the I channel and the Q channel signals. So that is what here the again the same short PN sequence code with the same offset is used to the further spread the signal, that is as shown in the figure. So the block interleaving and the process is raises the final synchronized messages at the rate of 4.8 kilobits per second. So the information contained in the synchronized message includes the system or network identification codes, identification of paging channel data rates, of offset value of the short PN spreading code, and the state of long PN spreading code, like the pilot channels and the synchronization channel as the fixed output power. So the next channel, it is a generation of Cdma paging channel, same as usual done in the synchronization channel. So here you are able to see that is the convolution encoder, symbol repetition, block interleaver, and that is getting multiplied, that is being getting multiplied at the rate of 19.2 kilobits per second, and been provided here one more extra block you are able to see here, the long code mask paging control channel, paging channel, and the long code decimator. Okay, so that is been getting added here and been provided, and it is going to generate the I and Q channel signals. So this is about the paging channel. Paging channel of IS-95 paging channels. Purpose is the property with the paging channel in the GSM cellular system. So the channels used to page the subscriber devices when there is a mobile terminated call to the send control messages to the subscriber devices when call setup is taking place. So figure shows the generation of paging channel messages for the IS-95 Cdma can be many as 7 pages in the channel in the operation at any one time. So the wash code 64 and the wash through the the 64 are used for this purpose. Okay, so the PN sequence is generated by using the 42-bit linear feedback shift register, that is LFSR, and deals with the repeating sequence of length 2 to the power of 42. So the paging channel messages also goes through the conventional and encoding process. So the symbol and the petition of the block interleaving before being scrambled and by the slower version of the PN sequence. So this is what the Cdma mobile station initialization station. So this is diagram, that is a state machine diagram for call enhancement from the mobile station. That is you are able to see that as in the case of GSM cellular, so Cdma system registration procedures are dependent upon the status of the mobile station. So the mobile may be either a detached condition from the network, or it can be a powered off or out of system range, or in and can be attached to the network. So when first turn on, the mobile goes through the power up state, during which it selects a Cdma system and then acquires the pilot and synchronized channels, which allow is to synchronize its timing the Cdma system. When attached, the mobile status dependent operation may be in one of three status. One is three states. One is the mobile station idle state. The other one is the access system state, or the mobile station control on the traffic channel state. So while in the idle state, the mobile monitors the paging channel. In the system access state, the mobile station communicates with the Cdma base station, sending and the receiving messages. So you are able to see when it is been power up, it been connected to the system destination subscriber. so which is going to create the CDMA system selected, then the pilot channel been created, then it is going to be synchronization channels are going to be created, and the timing to enhancement the call. This is what the procedure is required from the power up to the mobile station in ideal state. So this is about the CDMA uh, uh, network architecture, um, and the pilot channel synchronization channel. So next video we shall see about that is the CDMA mobile station call processing status. Thank you.